Did you know you don't have to use C language to program the Arduino? You have another option, the BASIC language, which is really simple. It's the beginner's all-purpose symbolic instruction code. It was made for beginners, and it's similar to what you used in the VIC-20 or Commodore 64 computers, but it's called GCBASIC, and it's designed for microcontrollers like the Arduino. I'll explain it all on today's Chuck Holloway's Electronic Products. Today's video is sponsored by PCBWay.com. Low-cost circuit boards, 10 boards for $5. And you can get standard PCB, you can get advanced PCBs, you can get flexible PCBs. Just upload your Gerber files and all the details that you want for the board, like solder mask, silkscreen, and they'll give you a quote. 10 boards for $5 plus shipping. In my case, about $27 to get 10 boards shipped to me. They also have CNC machining, 3D printing, sheet metal fabrication, and injection molding. So check out PCBWay.com. Now, if you're younger, you'd say BASIC, that's an old man's thing. And yes, I'm an old man. But BASIC was designed for beginners. And a lot of people will say, it's slow, it's interpreted, we want speed. Well, that's all true if you're talking about back in the VIC-20 Commodore 64 days. I'm talking a BASIC compiler. A compiler takes the commands or statements of the C code or BASIC code or whatever and turns it into essentially the ones and zeros that'll go into microcontroller. It'll break it down into an assembly file, and then that gets assembled into the ones and zeros. So if you're using the C compiler with the Arduino that comes with it, the popular Arduino C compiler, that's what you're getting. But they add a bunch of extra stuff in there to make it easier. Basically, to make the Arduino code similar to BASIC, because it was based on the BASIC stamp, which was the parallax module, which helped people get into microcontrollers before there was ever Arduino. The team that made the Arduino did all that on purpose because they wanted you to learn the C language in college, where this basically started, but they wanted to make it easy, like kind of the BASIC stamp could do. I mean, they were teaching BASIC stamp before they were teaching Arduino. So they wanted you to learn the C language in case you wanted to go on to a career in electronics, and for that, you want to learn C. But now with AI that can write a lot of your code, just getting a prototype working or just getting something to work from home, and you don't plan to become a software engineer or computer scientist, then a BASIC compiler is still really, really good. BASIC stamp was slow. It was kind of interpreted. It would do a fetch and retrieve from an external EEPROM. But compiled BASIC, which is what GCBASIC is all about, is actually more efficient than the C compiler that's used in the Arduino. Now, originally the GCBASIC was called Great Cow Basic, but it became GCBASIC because Great Cow doesn't really mean anything. But GCBASIC was originally developed for the PIC microcontroller, and I used it all the time with my CHIPINO module, which was kind of a clone of the Arduino, but with a PIC microcontroller instead of an AVR. The GCBASIC development team went back and rewrote GCBASIC to support both AVR and its existing PIC. So now you could program a PIC microcontroller or an AVR microcontroller with the same code. You just changed one line at the top to tell it which one you're using, AVR or PIC. And then within the Integrated Development Environment, or IDE, which they call GC Studio, it's the application you put on your computer where you actually write the code. They incorporated the Arduino bootloader. So now you can write your code, click a button, and it'll program it just like the Arduino IDE does, and you don't need a programmer like I use with the CHIPINO. I'll use my CHIPINO demo shield that I use with my CHIPINO modules, and it plugs right into an Arduino. This is the Arduino from that low-cost kit that I showed in the previous video. So now I can control these larger LEDs. Now I have open GC Studio on my PC laptop running Windows 10. So let's take a look at this simple program. At the top, I define what chip I'm using, and that's the Mega 328P that's in the Arduino. Then I'll do a do loop, followed by a pulse out command to pulse the pin that drives the LED, and I'll wait 900 milliseconds and then loop back and do it again. Now notice I use the pulse out. I don't think that command's available in Arduino. In the upper right hand corner is this HF button. That means create a hex file and then flash it into the microcontroller. So I click on that and it'll start building the program. It'll bring in the libraries and everything just like Arduino, and then it'll start assembling it and creating a program. Then it'll download into Arduino using the bootloader, and then you'll see the LED flash, meaning it programmed it, and now the LED is blinking on the CHIPINO demo shield controlled by the Arduino. Here's another sample that controls 4 LEDs. Now I'm using the Mega 328 because I'm using the Arduino. The 16 just indicates 16 megahertz is the speed. And then I set constants. I made constants LED 1 through 4 and tie them to the ports that they're actually connected to. Then here's a real basic loop. You just set the LEDs on and off with some delay, and it's got a go to in it. So go to start. That is pure basic. Then we go back to the right corner and click on the HF button, and it'll compile the program, bring it into libraries, and then it'll launch the bootloader so it can program the Arduino. You'll see the LEDs flash, and then it's programmed, and it'll start flashing the LEDs all the way across in a scrolling motion. And I just programmed the Arduino in BASIC. Now you may question, why use that then if it's the same as the Arduino IDE where it can just click a button and program? The difference is you're using an easier to understand language in the BASIC format, but also because it's a more efficient compiler than the C compiler in Arduino, you're going to use up less memory in the chip when you program it with the GCBASIC versus Arduino, because the Arduino puts a lot of fat in there to make it easier, where GCBASIC is easy because the commands are easy, and it produces really efficient assembly code. So that's why you can actually pack in more program into your existing Arduino using GCBASIC than you can with the Arduino C option. I used the Arduino IDE to compile that simple blink program, and it said it used 692 bytes or 8% of the program memory. When I looked at the GCBASIC, it only used 38 bytes, so significantly less. Another advantage to GCBASIC is it also supports other AVR microcontrollers and ATTINY microcontrollers. And so you're not locked into one platform. You can program any microcontroller. And if you're willing to use a hardware programmer like this one I showed in a previous video, this is an ATTINY programmer with an 8-pin socket, but it's also got header pins or pins for a header here, so you could connect to a board and program any ATTINY from this hardware programmer, similar to what the PICkit 2 does with 6-pin connections. Now, the fact the Arduino team used C to prepare people for industry, I think was a great move. I totally support that. But GCBASIC also allows you to take the basic commands and it'll automatically make them a comment and then show you the assembly code associated with that command. So you can actually learn assembly code by using GCBASIC, whether you use it with AVR or with PIC. And once you learn assembly commands and how to program an assembly, you are learning the lowest level bare metal programming, which if you're in industry and you understand bare metal programming, you got a huge advantage over a lot of people. And even if you're not planning to use it in industry, if you're a real tinkerer and you want to know what's going on inside that microcontroller, if you understand assembly code, and it's really not that hard. In PIC, there's only like 33 commands, and you're only going to use maybe 20% of them. Once you learn that, it's really, you're controlling the registers. You can control just about anything in that microcontroller. You can make some really efficient designs with a little bit 8-bit microcontroller. And that's where the advantage comes in over, say, 32-bit. 32-bit is getting cheaper, it's getting faster, it's getting better, but if you find a 32-bit like an ESP32 or a PiPico, you're buying a module, not a microcontroller. Now, there is a microcontroller in there, and you can build that into something, but in most cases, you find somebody building with that, they're using the module. Well, if you get down to where you need something really small or an interface, and you really need it efficient, if you know 8-bit microcontrollers and you can control it down to the assembly language level, without a lot of work because you learned it so easily with GCBASIC, that's a huge advantage in your projects, whether you're doing an industry or not. You're going to find you can do some very efficient things with your electronics once you understand this. Here's an example. It's an assembly program compiled by GCBASIC for a PIC, and all the commands are now comments. So you can see the assembly code. So set LED off is bit clear, port B, bit 3, and wait delay, it loads a value and then does its routine to delay that amount of time. So it's really easy to learn what the assembly code is doing. Now, I'm not necessarily trying to sell you on GCBASIC, although essentially it sounds like I am, What I'm saying is having more tools in your toolbox is what I recommend. No ESP32, no PiPico, no Arduino, but also don't throw out GCBASIC, don't throw out PICs, don't throw out little 8-bit microcontrollers because, oh, that's old school, I don't need to know that. No, I'm telling you, you need to have that in your toolbox. Some people use it more than others, but just if you're starting with electronics, 8-bit is an easy place to start and then grow into ESP32. Some people say start at ESP32. Most of those people started with Arduino and worked their way up, and they forgot what it was like when they were starting. I'm telling you, if you're just getting started or you just want to fool with simple stuff, 8-bit is perfectly fine. ESP32 and 32-bit is all great. You can download code. You can make some really fantastic projects. If you want to connect to the internet or you want to do any kind of communication like that, don't use 8-bit. Use the 32-bit and use those modules because that's what they're designed to do really, really well. But if you just want to control a robot, if you just want to do a simple sensor, if you just want to do a simple project to control a robot head or something like that, 8-bit actually does a lot of things really, really well. So having that in your toolbox as one of your skills is something that I still highly recommend. I have had viewers ask me when I'm going to start doing projects to show you can do it on Arduino, CHIPINO, or microcontrollers, and I'm working on that. It takes more time to make those kind of videos, and also I want to get the fundamentals out of the way. But there's also a ton of videos already out there showing you what you can do with Arduino. Now, I will add some because CHIPINO is not that big yet. I'd like it to be bigger. But the whole idea is there's a lot of stuff out there. So I'm trying to teach more of the fundamentals so you're prepared. But I also want to introduce you to the other options to put in your toolbox. And a great resource for GCBASIC is none other than the GCBASIC channel. The GCBASIC channel is actually run by Venn, who's one of the lead developers of GCBASIC. And he knows it so well, and he'll go through all kinds of details that I can't even cover because he knows it so well. He does a lot of PIC, not necessarily CHIPINO, but PIC, microcontroller, and some AVR. But he also shows you some of the extra tools that are built into GC Studio. Like some of the PIC microcontrollers have logic blocks in them with actual logic gates, and you can control that from code. It's almost like a simplified FPGA built into the microcontroller, the 8-bit microcontroller. And he shows that there's a tool right within GC Studio that helps you just define those logic blocks, and the code is automatically spit out. It's very, very simple. And now the microcontroller is running just like a ASIC or a FPGA. It's just running the logic. It's not really running code. It's physically running on the logic circuits inside the microcontroller. So that's why I bring all this up. It's not just about C versus BASIC or 32-bit versus 8-bit. It's about learning electronics. And these are areas that if you search the whole YouTube universe, you'll only find very few videos covering this stuff. And that's what I'm trying to cover because I don't want that art lost. As more people use 32-bit, more technology moves on, the older stuff gets forgotten. And as Elon Musk said, the pyramids, the ability to build the pyramids in Egypt, that technology, that knowledge was lost over generations. So technology doesn't just naturally get better and improve. It can go away if you don't keep using it. And there's still features in the 8-bit stuff that we're not using. And the nice thing is GCBASIC or GC Studio, which is what you would install, which is the IDE and everything, it runs on a Windows platform. You install that, it's free. It's free to use. There's no subscription. There's no add-ons that you got to pay for. It's all free and it's all open source. And this has been around for a long time, like over 25 years, that people have been continuing to make this better. So you could program 8-bit microcontrollers, either AVR or PIC. I think there's even an LTR microcontroller in there. But then you can use the code and you can use it in some simulators. Now, the Tinkercad Circuits doesn't allow external hex files, but some of the other ones do. I believe Wacwi is a simulator for Arduino. They allow you to put a hex code, load a hex code file that you made with GCBASIC and then run it in the simulator. So you really don't have to spend any money to play with this and try these things out. Now there are PIC simulators out there, not as many as Arduino and certainly not as advanced as some of the Arduino simulators. I wish someone would take my CHIPINO and incorporate that into one of these like Walkly or something like that. I've asked them, they always say, oh, they ain't got time. But the idea is there's PIC simulators as well. You can use the GCBASIC code and simulate it. So again, that's for free. So there's a lot of options to learn. And so what I'll do is I'll link to the GCBASIC channel in the description below. So you can go check it out, watch that, and maybe try some simple things without spending any money. See if you even like GCBASIC, or if you have an Arduino module lying around, try it out with the GCBASIC in GC Studio, and tell me what you think about it in the comments below. And a big thank you to all my Patreon supporters who make all this possible. If you guys need anything, you can get a hold of me through Patreon. Thanks for watching. And if you like what I'm doing here, maybe check out some of the other videos popping up. If you want to help support the channel, Patreon's the best way to do it. And if nothing else, click on that CHEP logo and subscribe. I'll see you next time right here at Chuck Hullabuck's Electronic Products.